Hi everyone, welcome to the short talk on developing and evaluating automated writing scoring models. In this presentation, I describe the considerations, procedures, and preliminary findings from the work to move a human rater-only system towards a system that incorporates machine scores in addition to human ratings. Automated writing evaluation or AWE systems use various artificial intelligence, natural language processing, and statistical techniques. Its efficiency and scalability make it an attractive option for conducting ratings. It has been shown to be able to provide scores that are highly correlated with human judgments, and in many cases, these scores are also in close agreement with human scores. In its early stages, automatic writing evaluation system typically relies on surface-level language features. One primary concern about using machine scores is that they cannot fully represent the construct of interest. On the other hand, human raters can comprehend the meaning of the essays, consider multiple aspects in their judgment, and evaluate complex constructs such as creativity and critical thinking. In this study, we consider incorporating machine scores in the current human rater-only system to elevate the workload, improve efficiency, and maintain high-quality ratings. Let's first learn a little background information on the writing assessment itself. The writing assessment consists of two types of prompts: writing an email and responding to a survey question. Test takers read the instructions and writing prompts on the screen, then write and edit their response to each writing task on the computer. With the human-only rating system, all writing tasks are rated by human raters according to a standardized analytic rating rubric. Each writing sample is evaluated by two independent raters, and significant disagreements among ratings will be resolved by a third rater. We are conducting an exploratory study because there are some challenges in developing automated scoring models for this writing assessment. First, a wide range of proficiency levels with 11 possible scoring points is reported. The writing samples are relatively short, about 118 words. Additionally, it serves a diverse test taker population with different language, cultural, and educational backgrounds. Here we describe the general process for developing and evaluating an automated evaluation system. It started with data preparation, including collecting, selecting, reviewing, and pre-processing the data to be used to train the model. The data was split between the training set and a small initial testing set. One scoring model was trained for each writing task type, W1 and W2. The two colors in this flowchart separate different teams taking primary responsibilities at each step. The two boxes in dark gray are the main tasks, while the models are built. Data scientists and engineers often handle them. The other orange boxes are supporting tasks, while input from multiple teams who are familiar with the test, the rating rubric, and the rating data provide data for the training and feedback. Language assessment experts and psychometricians handle these tasks. We trained two models, one for each writing task type. Using the techniques drawn from artificial intelligence, natural language processing, and statistics. To train the models, we select writing samples covering broad proficiency levels from a diverse test taker group. To ensure the quality of the ratings provided, we select responses where raters agreed in the primary judgment round. Additionally, internal staff reviewed many of the selected samples to ensure the ratings were reflective of the writing performance level. Last, high-quality rating samples used in rater training and certification were also included in the training set. After the initial model were trained and validated on a small sample, they were applied to score an independent sample of 271 writings. Analyzing the model performance on the small testing sample lays the groundwork for more comprehensive model evaluation later. It also sheds light on where the model needs to be refined. The graph on this slide illustrates the agreement between human and machine scores by proficiency levels. In addition to agreement statistics, we also investigated correlation between machine and human ratings. Equally important, we reviewed the writing samples with the largest disagreement between machine and human assigned scores. The results from the initial model testing show satisfactory overall agreement with human scoring. The machine scores show the central tendency at level 8, and as a result, the agreement levels are low at the high end of the score distribution. At the lower end, the machine cannot accurately identify off-topic writings or accurately grade templated responses. Together, the findings of this study show that automated scoring models are a promising addition to mark essays for the writing assessment under consideration. As suggested by the literature, with well-trained scoring models, machine scores can provide consistent, objective, and speedy ratings across a large number of essays. It enhances the scalability of the assessment to handle large volumes of test takers. Acknowledging the limitations of automated evaluation systems, such as being unable to evaluate originality and creativity, we plan to use machine scores in conjunction with human ratings to ensure a reliable and valid writing assessment. At the same time, our initial findings suggest that there is room for the models to be improved and refined with more input. More studies will be conducted to evaluate the models to ensure they are valid and fair to all test takers. Thank you.